one of the things we do when we come up against a new function, and the name of this section, section 2.4, is called quadratic functions. Quadratic functions and their transformations. In chapter 1, we were talking about linear functions, and one of the functions that the course chose to look at was the absolute value function. Remember this? I don't know if I hope you remember this. I shouldn't say I hope you remember it. You should remember it, the absolute value functions. And this is what it looked like, if you remember correctly. It looked like that. It looked like that. That was the parent function. Remember, there was something called a parent function, which is kind of the most basic form of it. And we even had a formula which we described as f of x equals a times the absolute value of x minus h plus k. You all remember this. And I said that hk was the vertex. I called it the vertex. And the h told us how to move the function, either to the left or to the right, and the k told us how to move it up and down, and we did all kinds of things. And when the a was negative, it turned it upside down, right? We did all of that stuff. That was when we were talking about linear equations. And they chose absolute value functions as their test case. Well, in this chapter, we're going to be talking about quadratic functions. And in fact, in the chapter after this one, chapter 2.5, we're going to be talking about higher degree functions, which will really be fun. But we're going to be talking about now the quadratic function. And the quadratic function is f of x equals x squared. And one of the things we'd like to do to start with, of course, is to see what this looks like. Okay? So let's, a sketch. We're not going to graph it, because I know that people don't have graph paper, and I don't want to take the time to start fiddling around with graph paper. Let's just get an idea as to what at least the parent function will look like. So when x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 4, right? See, because it's being squared. When x is equal to 3, y is equal to 9. Well, if your initial inclination is to draw a straight line, it's not a straight line. Like here, when x was 1, y was 1. When x was 2, y was 2. When x was 3, y was 2. That's a straight line. But here, x is 1, and then it goes to, y equals 4, and then it goes to y equals 9. And if we went out to 4, 4 squared is 16. So this is actually going like this. And it's kind of curving up. And then going in the negative direction, when x is -1, it's still going to be +1, because we're squaring it. -1 squared is 1. -2 squared is +4. -3 squared is -9, and -4 squared is +4. positive 16. I'm remiss if I don't curve this up a bit. So let's make it look like it's a curve, a little off there. And this is the parent function. This is the parent function for f of x equals x squared. It is extremely similar. My goodness, this is a linear function. This is a quadratic function, but wow, they look almost the same, except that this is, this is quadratic, so it's moving up faster than this. This is just kind of lollygagging its way through the plane. This is just zooming up, for 4, it's going to be 16. For 5, it's going to be 25, and it's going to go like that. And to make it even more similar, we can even say that f of x will equal a times x minus h squared plus k, where h sub k is equal to the vertex. Look at the similarity between those two graphs. It's very, very interesting, right? And yet there are differences. So obviously that's what we're going to be studying during the first part of this class. So, what does the HK actually do? Well, let's look at a few possibilities. Let's look at f of x equals the see, now I have to get my mind out of the absolute value. So, if you look at that, basically you're saying that it's the same graph as the parent function, except rather than that, it's going to be starting up here, and this is the way it's going to look, which is obviously exactly what the parent function of the absolute value would look like, except that, it's absolute value instead of, it's not a curve. And if we made this f of x equals x squared minus 1, then we're starting with a vertex, and this is really the vertex of 0, 1, and this is 0, -1. And it's going to look like that. In fact, f of x equals x minus 3 squared plus, well, let's not go that far. Let's just stick with it in its simplest form. Okay, well, what does this mean? -3. Remember what I said when we were doing linear functions, that -3 really means that we're moving it in the positive direction. So this is the point 3, 0. And the function will look like this. And when it's f of x equals x plus 4, let's say, squared, then we take the opposite of +4, is -4, and that's what the graph will look like. So this is all very, very similar to what we just looked at when we were talking about linear functions and absolute value specifically. Let me get rid of this. Excuse me. And bring up this. Okay. Okay. So let's take an example. So f of x, and keep in mind that when we talk about f of x, we're really talking about y. So, and sometimes it's easier to graph y equals the function than it is f of x equals the function. But let's take an example. Let's say we have, there's one thing I forgot, which I wanted to talk about. Let me do that before we continue. Let's say we have f of x equals negative x. Remember this? Negative the absolute value of x. What does that mean? Somebody tell us.
This is rows, you flip it.
Good. Use the mathematical terms. That would be even better. Rows, you nailed it, but what did we just do? We flipped it. That's the way we talk to make it, easy for everybody. But what's the exact term that is used?
Is it inverse?
That's not what I'm looking for. I'm looking for a particular thing. And somebody here knows it. I know that.
It's not conjugate, is it?
No.
No, sorry.
Flexion.
Conjugate is always a good answer for pretty much everything, right? But not here. Not enough of this one. This is called going once, going twice. That's it. This is called a reflection. If you take a graph, in this case, the parent function, and you reflect it in the x-axis, this is what it looks like. This is called a reflection. Okay? If this was an intermediate algebra class, I'd say, oh yeah, that's flipping it. But this is pre-calculus class, so we're gonna call it what it is. It's a reflection in the x-axis. Okay? Let's take an example. X minus 2 minus, well, let me not send it up, sit down so low. Excuse me. Okay. Whoops. Okay, so we want to graph this. Usually when you graph something like this, the very first thing you do is you look for the vertex. And the vertex will be the opposite of -2, which is 2, -3. All right, as we go along, I guess we should kind of, graph it and see what this thing looks like, right? So we're going to start at 2, 1, 2 in the x direction, -3 in the y direction. This is where it is, 2, -3. And we know that, we know what's going to happen at this point because we know what the parent function looks like. So all we need to do is to go like this. And, and honestly, we don't know where this thing goes. Does it hit the y-axis over there? Does it hit the y-axis over there? We don't know any of that stuff. And that's the stuff that we need to know. So in this chapter, we're actually going to go a little bit further than we did when we were doing absolute values. We're going to figure out where this thing crosses the x-axis. I'm curious myself, do I go like, if I'm giving you a sketch, is the sketch going to go over there? Is the sketch going to go over there? Is the sketch going to go over there? I mean, where is this thing going to go? Can we figure that out? The answer is not only can we, but we're going to. So you need to know a couple of things. Let's get rid of this, if I might, because this is not, this is what we don't know it's going to look like. Let's just graph what we do know so far. For example, we know that this is the vertex right down here. 2, -3. And we know that it goes up. We know it goes up because there's no negative in front of the function. So that's good. But we would like to know a few other things. And one of the things we would like to know is what's called the axis of symmetry. We want to know what the equation of that line is. Because whatever we have on one side of the line, we're going to have on the other side of the line. So that's kind of important. So the next thing we're going to look at is something called the axis of symmetry. The axis of symmetry is equal to x equals the, whatever this is. You see what it goes through the point where x is equal to 2? Therefore, the axis of symmetry is x equals 2. So that's easy because the axis of symmetry is always going, if the vertex is hk, then x equals h will always be the axis of symmetry. Okay, so that's easy. If hk is, if this is h and this is k, and the axis of symmetry goes through the h, then x equals h is the axis of symmetry. In this case, x equals 2. Yeah, but that's good to know. But I'm really, what's really interesting to me is what happens over here. I don't want to draw an incorrect graph for the class. I want to draw what this thing actually looks like. Does it go through, what does it look like? So let's find out. So what we want to find out are the x-intercepts. That's very important. Where does this graph go through the x-axis? So one of the things we need to find are the x-intercepts. Okay, so we have y equals x minus 2 squared minus 3. Now, what is an x-intercept? Somebody define it for us. The x-intercept is what?
The points on the x-intercept in which the lines cross it.
Oh, I need a definition that will help us to solve this problem. In other words, I need somebody to say the x-intercept is the value of x when something happens. What
When
needs
y
to
is
happen?
0,
Say it.
when y is 0,
Who said it?
Allison,
Very good. Very good, Allison. While we're here, Allison, we might as well talk about the y-intercept, right? Because we're going to be going there as well. So the y-intercept is the value of y when, somebody else, when something, not Allison, somebody else. If the x-intercept is the value of x when y equals 0, then the y-intercept is the value of y when what?
X equals 0.
Good. Who said that?
Rose.
Good. Very good. Nice going. Now we're all set. So we want to get the x-intercept, we let y equal 0. And this is where we are. Well, that's not the greatest place to be, is it? Because now we have to solve this thing. It's nice to know that that's how you do it, But let's now do it. Now, the first thing I'd like to do is turn the whole thing around. So I'd like to make this x minus 2 squared minus 3 equals 0. And put this calculator over there and put the pointer over there and get the eraser out of the way. Okay, so we've gotten everything out of the way pretty much. Okay, well, how do we do this? Well, let's bring over the 3. This is how I would do it. Now, I'm not gonna square this and try to solve the quadrant. I'm gonna make it as easy as possible. So x minus 2 squared is equal to 3. Take the square root of both sides of the equation. X minus 2 is equal to the square root. Let me put it over here. X minus 2 is equal to plus or minus the square root of 3. Well, let's just go all the way with this. Let's bring it over there and let's get x equals 2 plus or minus the square root. Does anybody know the square root of 3? Does anybody know the year that George Washington was born? Some of you are probably saying, uh-oh, this is when the professor cracks up. He's relating this to George Washington's birth year. Let's call the dean, call the chairman. It just so happens that by some fluke of nature, the square root of 3 is the year that George Washington was born. And since I'm a history fan, I happen to know that George Washington was born in that year, 1732. But if you weren't a freak of history like I am, it's very easy to find. You would simply turn on your calculator and find the square root of 3. And there it is, 1.732, just to prove to you I'm not crazy, or I may be crazy, but that's not so I didn't make a mistake. And we always do things to the nearest 10th. So let's do that. So now the very last step of this problem is going to tell us where along the x-axis this line is, the graph is going to hit. So x is equal to 2 plus 1.7, and x is equal to 2 minus 1.7. So let's do this. So x is equal to 3.7. So we know that if this is 2 and this is 3 and this is 4, that the graph is going to go through the point over here, 3.7. Now, what happens over here? That's interesting, right? Because it looks like it's going to get very close to the y-axis. So this is the y-axis, the x-axis. So let's see, what does this look like? X equals 0.3. Indeed, right? It gets very, very close. It doesn't even get to 1. It goes right there. So that's very helpful. It doesn't actually cross the y-axis until it gets above the x-axis, and then it's going to go like this. So this is what the graph looks like. That's very interesting. Okay, so here are the x-intercepts, 3.7 and 0.3. But where exactly does it cross the y-axis? Now we find the y-intercept. So we go like this, y equals x minus 2, the original function. And now to get the y-intercept, we let x equal 0, 0 minus 2 minus 3, y equals -2 squared is 4, 4 minus 3 is 1. The y-intercept is y equals 1. And that's not hard to believe, is it? Because here it is right here. So all this is very, very nice. So, this is going to be 0, 1 for the y-intercept. The x-intercept over here will be 0.30. The x-intercept will be 3.70. And now we know exactly, not exactly, but very close to what this graph is going to look like. Okay? And that's the complete problem.
Solving for the y-intercept, the 0 you put, that's what the x is, right? 0 minus 2, the 0 was the x.
Yes, exactly. The definition of y-intercept is the value of y when x is equal to 0. So I let x equal 0. 0 minus 2 is negative 2. Squared is 4. 4 minus 3 is 1.
So when you're solving this, that will always be 0? Is
Yes.
x? Okay.
Yes, absolutely. These are absolutes, no pun intended. These are absolutes. These are rules. Okay, what Allison helped us with before were rules. The x-intercept, the rule is the x-intercept is the value of x when y is 0. The y-intercept is the value of y when x is 0. That's what helped us to graph this thing. Okay? Good question, though. I mean, that was a very good question. I like that very, very much. Okay, so here are your instructions. Find the vertex. Find the axis of symmetry. Find the x-intercepts. Find the y-intercepts. Y-intercept. There's only one. It only intersects the y. And step 5, sketch the graph. Okay, so, give it a shot. I'm going to begin. Now, if you're in the middle of doing it, you can keep doing it as I'm talking. If you haven't done anything yet, then, it's very important that I at least push you in the right direction. So let's start. Now, the first thing I ask for is the vertex. You can abbreviate that with a V. Okay? Now, we know that it's going to be the x coordinate of the vertex will be the opposite of +3, which will be -3. And the k will be -1. So that's straightforward. Very nice. Axis of symmetry. Axis of symmetry. X equals -3. Okay, so the x will equal that number. That's what it's gonna. And we could, at this point, we could start to graph it. All right, so let's take a graph. Now the vertex is -3, -1. Here it is, right down here, -3, -1, and the axis of symmetry is x equals -3. Okay, so we know that the graph will have a vertex here, will start to go up like that. But we don't know where it's going to hit the x-axis, so therefore, the next thing I'm going to do is find the x-intercepts. Okay, so this is the x-intercepts. So I'm going to take x + 3 squared -1 Remember, this is y, so that's equal to y. I'm letting y equal 0. Letting y equal 0. I'm bringing over the 1. X plus 3 equals 1. Okay, I'm just checking over my work. Squared, don't forget to square. Take the square root of both sides. Thank goodness we're not going to have anybody's birth year now. And this will be plus or minus 1. This is good. This is good because when you don't have to use your calculator. So -3, -3, x will equal -3 plus or minus 1, which is, this is going to give us the x-intercepts rather quickly because x will equal -3 plus 1, x will equal -3 minus 1. Does that make sense? Yeah, it does. Well, let's, continue. Let's not get carried away with ourselves. The x-intercept is -2. Yeah, that makes sense. And x equals -4, right? So here's the x-intercept. You can even write it, x-intercept. I don't like, oh, this is, yeah, okay. Okay, and this is an x-intercept as well. Okay, so what do we have here? -2. Well, here's -2, approximately, right? Can't get it exact. And here's -4. So this is the point, -4, 0. This is the point, -2, 0. It's going to go like this. Okay, it's going to go like that. It's headed up. We don't know, but we don't know much about this line after it leaves the x-axis because we don't know where it touches the y. If we knew where it touched the y-axis, then we could use the axis of symmetry, which will help us on the other side to figure out what's going on. So now the next thing we're going to do is find the y-intercept. Okay, but first I'm going to look at this. See, this is why it's a very good idea if I made a mistake for people not to tell me. Because, I'm just looking back now to make sure I didn't do anything wrong. And that's what I'm doing. And hopefully if I made a mistake, I'll find it. So -3, this looks good. -3 plus or minus 1, okay. And -2, -4, good. -2, -4, okay, very good. Now the y-intercept is the value of, so let's see, y equals x plus 3 minus 1, and the y-intercept will be the value of y when x is 0. So 0 plus 3, -1, y equals 3, well, squared, right? Forgot to square. See, I knew this wasn't, I realized it wasn't going to work because if the y-intercept was 3, that's too far down. It's got to be higher because look at this graph go up. You see how it's going up? It can't possibly hit it at 3, which would be around over there. It's got to hit it like up here, in my opinion. And that bears truth over here because this is now 3 squared is 9 minus 1 is 8. The y-intercept is equal to 8. In other words, the point 0, 8. And that's going to be, up here, which is perfect. Look at that thing, go right up through there. And here it's going to just go up like that. I had to lean it a little because I wasn't right, but it's really going to kind of, let's do a really good job. Let's not, let's not do it haphazardly. Let's make sure I mean, we're not using graph paper, so obviously you're not going to get an exact, but it's going to look like that pretty much. And that's the end of the problem. Let me review. Let me review this problem. You're given a function, a quadratic function. First, you find the vertex, -3, -1. Very good. Okay. Then the axis of symmetry, x equals -3. Very good. That's great. Now you need to find the x-intercepts. We did that. I kind of checked it over again already to make sure. The x-intercepts are -2, -4. There it is, -2, -4. But we need to know how far over it goes. So we found the y-intercept, which turned out to be 0 + 3 - 1. 3 squared is 9, -1 is 8. So it's going to go like that. And this, you could label this point, you could label the y-intercept 0, 8. So that looks very nice as well. That's the perfect answer to the problem. And that's it. That's the way it looks. That's how you graph a quadratic function. Anybody have something to say? That's the function. So you should be looking at this and saying, whoa, this is not what he's been doing for the past hour. What's going on here? This doesn't look like this. I know how to graph this. He just showed us and gave us a problem to try. That doesn't look like that. Well, what we need to do is take this quadratic equation and make it look like this. And this is the way it's done. So y equals, as I keep saying, y is equal to f of x. This is, a given. So x squared minus 8x plus 7. This is how we do it. We're going to do the process of completing the square, but we're going to do it in a different way. We're going to switch the form. Switch the form of the quadratic equation from this form to this form. And the way we do that is by using the concept of completing the square. Okay, so this is going to be switched to this form, and then we'll be able to graph it. So what we do is the following. We say y equals x squared minus 8x, and I'm going to take that. I don't want to bring the 7 to the other side of the equation. Like whenever we did, completing the square, we always brought it to the other side. We don't do that here. What we do is we simply take that 7 and put it over there as a spectator. It just sort of moves over. So it's not in the way. We're not going to move it to the other side because that'll complicate things even more. Let's just move it over and leave this the way it is. See how much easier it is to look at this than look at that? Now we do completing the square. Well, half of 8 is 4. 4 squared is 16. But I can't really go over to an equation and put a positive 16 over there So what I do is, at the same time, I put a negative 16 on the same equation. So it's different from the previous completing the square, where we did it to both sides of the equation, because we're only working with one side of an equation. So we added the 16 as we normally would when we complete the square, but then in order to make it so that we haven't altered the equation in any way, we do a negative 16 on the other side. All this is legal. And now let's work with this. So this is like over here somewhere. And we'll get back to it. We're not going to just abandon that. But this is going to be x minus 4 squared. This is completing the square. Take half of the 8 is 4. 4 squared is 16. There it is right there. Now, what's 7 minus 16? That's negative 9. Here it is, back to this form. And everybody should now be saying to themselves, that is just beautiful. If anybody says, wow, that is just beautiful, they immediately get my admiration. You thought I was going to say extra credit, right? But you can't do that because everybody would yell out beautiful. But you do get my admiration. But I hope you understood what I did. Let me repeat that, because that's the most important thing we just did, and very different from what we did on the previous board. So what I did was, I said, well, this does not look like it's supposed to look. When it looks like this, we could take the vertex, we could take the axis of symmetry, we know how to find the x-intercept, the y-intercept, everything is beautiful, but it doesn't look like that, so we have to make this, as I said earlier, make this look like this. And this is the way we do it, by completing the square, but the 7 is in the way. So what do? We push the 7 over, and then we complete the square. And we take half of 4, we square it, we get 16, we add 16, but you can't just add 16, you have to also subtract it, and you do that over here. And when you put these two together, you wind up with negative 9. And this is what you get over here. And now we're all set to graph it. Okay, so let's get going now. So let's see, the vertex. The vertex is going to be the opposite of negative 4 is 4, negative 9. The axis of symmetry is x equals 4. Okay, so we could kind of begin, right? So the axis of symmetry is 4, negative 9. It goes down here, 4, negative 9. It will come up. We don't know where it's going to intersect the x-axis. I'm not even going to, I'm not even going to guess. I'm not going to say it's over here and over there, because who knows where it goes. But now we need to find the x-intercepts. The x-intercepts. Okay, so let's take the original. Y equals x minus 4 squared minus 9. And let's let y equal 0. The x-intercept is the value of x when y is 0. And turn it around. I hate when it looks like that. I just can't. You could do it. I could probably do it, but I'd rather, keep it comfortable. Okay, so x minus 4 squared. Let's bring the 9 over, right? Let's take the square root of both sides of the equation. we get x minus 4 equals plus or minus, that's good, right? A rational number. The square root of 9 is 3. That's good. All this is good. Everything's moving along well. We don't need these parentheses anymore. Let's get rid of them. We've already gotten rid of the square because we took the square root of it. So yeah, what we did is that thing we keep doing constantly. The square root of a number squared is equal to what's inside, right? So so x minus 4 squared, the square root is just whatever's inside. Plus 4 on both sides. X will equal 4 plus 3, and x will equal 4 minus 3. Those are the two intercepts, and that will be x equals 7. Can you see that? And x equals 1. Here are the intercepts. Very nice. So we know now that at 1, when x is equal to 1, that's going to be one intercept. And when x is equal to 7, well, it's, I've kind of, see, this is why it's not a good idea to sketch it until you have more information, right? Because you want to know, how much this thing goes apart like that. And there's the intercepts. But we want to know, how far over this goes. So we need to find the y-intercept. So let's see let's go back to the original y. Well, I got a little trick for you. You ready for a trick? You ready for a trick? I think you're ready. Watch this. This is a beautiful thing. Rather than do it the way we usually do it, which is to let x equal 0 and find y, here's the y-intercept right here. Look at this. What's the definition of the y-intercept? It's the value of y when x is 0. Well, if x is 0, this term drops out. When x is 0, this term drops out, and y is equal to 7. That's the y-intercept. 0, 7. Here, it's going to go right over here. 0, 7. In that direction. And that's the end of the problem. Oh, the axis of symmetry. Well, we didn't do that, did we? It's a little crooked, but it doesn't matter. X is equal to 4. That's the axis of symmetry. And that's the graph. Okay, I'm going to give you some time to try this. Just one thing. What's one thing? There is a difference between these two expressions. This is the equation, obviously, in a different form from the equation that we're going to now be putting it in using completing the square. This is called the general form of a quadratic equation. In other words, when you get an equation that looks like this, it's called general form. Just to distinguish between the two forms, when you get an equation that looks like this, with an A in front of it possibly, right? This is called standard form. And then this is important because, we're going to be throwing it back and forth, going from, so in this problem, you're actually going from general form to standard form, and then you're being asked to, answer all these questions. So the method of going from general form to standard form is called the method of completing the square. That's really what we're doing. That completes the entire thought. Now let me begin doing this. Okay, so I take the problem. Y equals f of x which equals x squared minus 6x plus 5. And let me drop this down a bit. Okay, so the first thing we want to do is really, and this, I didn't put this because I didn't want to overwhelm everybody. But as I was looking through the homework problem that I gave you, there's only one homework problem based on this whole thing. And the problem actually, indicates general form and standard form. So what we're doing when we do this problem is we're changing the equation from general form to standard form. So let's begin. So again, what I'm going to do is take this equation let me make sure I do this in such a way. Let me not put the y over there. I like to put the y over there, but let's not do it in this case. Okay, here we are. So once again, the first step is to take that 5 and sort of push it on the side. So we take x squared minus 6x, and this 5 will sort of be moved over like that. It's not out of the problem, because obviously we're going to use it very soon, but it's kind of away from everything while we do completing the square. Next step, we take half of 6. Remember the process. We take half of the 6 is 3, 3 squared is 9, and we add that on there. But again, you can't just add a positive 9 onto an equation without also subtracting the 9 over there. Okay, so all this is being sort of pushed to the side while we, put this into standard form. So we take half of 6 is 3, 3 squared is 9. We add 9 here, which gives us the ability now to do this. This can be factored into this. Actually, let me go one more step. Just, so people may not understand that. So what I did was I factored this into x minus 3, x minus 3. If you were factoring a trinomial, how would it be factored? Like this, but this can be written as x minus 3 squared. Okay, so that's that. And now let's do this. Now let's bring this into it. 5 minus 9 is negative 4. And this is the first part of the problem. We have changed from general form to standard form. And now let's answer all the questions. The vertex. The vertex it's the opposite of negative 3, which is 3, negative 4. And the axis of symmetry x equals 3. Okay, so that's what we know just by looking at the equation, right? And I'm not even sketching it because I don't want to start sketching it and it may not look, right. Let's go right to finding the x-intercepts. Okay, so let's take x minus 3 squared minus 4. And, this is equal to, that's when, this is really what I have. See, this is when it's a good idea to put the y over there. So you're constantly moving the y back and forth. It's here, now it's there. Now we're going to make it equal to 0 because the definition of the x-intercept is the value of x when y is 0. So let's let y equal 0. Now let's bring over the 4. Again, that's very, very good. That just didn't happen. I created a problem which would make it very, very good. X minus 3 will equal plus or minus the square root of 4 is 2. That's good. That's good. I add 3 to both sides. X will equal 3 plus or minus 2. All right, now I'm going to move it up because it's getting kind of, down too far. So I'm moving this up to x equals 3 plus 2 and x equals 3 minus 2. X is equal to 5. X is equal to 1. These are the x-intercepts. And this is, it's better anyway to get back up here because now to find the y-intercept, you remember that I gave you kind of like an easy method of doing that. If you go back to the original form of the equation, the general form, y equals x squared minus 6x plus 5, right? So how do you find the y-intercept? You let x equal 0. That'll drop out. Let's actually do it just to show you at least one example where y it actually drop. 0 squared is 0. 6 times 0 is 0. Y is equal to 5. The y-intercept is 5. Or on the graph, it'll be 0 for x, y is equal to 5. And this will be 5, 0, and this will be 1, 0. All right, so we now have everything we need to do the graphing. So now I can create a sketch, the y-axis, the x-axis, and we want the point, the vertex. That's the starting point. 3, negative 4. 3, 1, 2, 3, negative 4. We could make it, even though we're not looking, we're not using graph paper, we could certainly make it look, decent, right? So let's do that. And the vertex is 3, negative 4. 3, negative 4. The axis of symmetry will go right through the point, x equals 3, right through the vertex. That's x equals 3. Here's the axis of symmetry right over here. X equals 3. The vertex over there. Now, the x-intercepts are 5 and 1. So we need to extend this. This is 4. This is 5. Here's the x-intercept. Here's the x-intercept. The y-intercept we know is 0, 5. So that'll be like, following through with this. 2. Well, that you see, I kind of saw myself running out of room, but that's not the way you do math, right? When you run out of room, you just interfere in a different problem over there. Okay, so this is what it looks like. Goes like this, and we'll go like that. We'll go like this, and we'll go like that. But, it's interesting because it intercepts at 1, right? But it doesn't hit the y-axis till 5. So it's going to kind of move slowly up here and then intercept the y-axis. And that's the whole graph.